Algebra 2, welcome very much to another special edition on how to go from general to vertex form with dilation variable, okay? If you look at the previous examples that we did, you should see that we had something like y is equal to x squared plus 8x, right, plus 3. Well, if you notice, what's the number in front of x squared? Yeah, it doesn't show it, but it's just 1, right? It's just 1. Well, over here, it's 2. All right, and so when we want to work to go from general to vertex with a dilation variable, okay, we want to be able to focus, we want to somehow change it to look something like this, where we can see x squared just to have a 1 in here, right? So ideally, I just want a 1 in here. So when we work through this, we just got to think to ourselves, okay, what can I do so that I can get rid of the 2 from the x squared, right? How can we distribute it out? How can we pull it out? For example, let me give you an example here. Let's say we have 2x plus 3. Okay. Oops, I wrote that terribly. So let's go ahead and draw 2 times x plus 3. All right, well, 2 times x is 2x plus, what's 2 times 3? Well, that's 6. Okay, well, let's say I wanted to go backwards. I wanted to pull the 2 out, right? So let's say we got 2. Okay, we know this should be x plus 3. So what can we do to this so that we can get the x plus 3? Well, what we can do is we can divide this by 2, right? Because that's the number in front of x, so we get x because 2 divided by 2 is just the 1. And if we divide this by 2, well, that's just going to give me the 3 there, right? So if we have to multiply to distribute this out. So when we want to pull the 2 out from these expressions and put it here, we have to divide. All right, so we're going to use that as a guide. Hopefully you wrote that down if you needed it, all right? And we're going to pull the 2 out. So we're going to get y is equal to 2 parentheses, right? And we're only going to do it to the first 2 terms, right? We purposely don't really care about the plus 3 out here. And the reason why is because, remember, our factored form looks, our vertex form looks something like this. All right, we only want to pull out the variable, right? That's an a. We want to pull out the variable, in this case it's a 2, only from the first 2 terms, because in vertex form we purposefully want the number on the last to be left alone, because it's going to tell us whether we went up or down when we go to get our equation. So we actually don't want to mess with the last term. Okay, so let's go ahead and get started, right? If we were to divide this both by 2, we're going to get x squared plus 8x, okay? And then we still have this plus 3 out here, right? Now you can believe me and you can see, right? Well, what's 2 times x squared? Well, that's just going to give me this back up here. And what's 2 times 8x, right? Well, 2 times 8 is 16, so that gets me right back up here. Great. Cool, so we kind of have an idea of how we want to do this and how we're going to work with it, right? So as you can see, we want this to become a perfect square, right? Now that we pulled the number out, we want this right here to be a perfect square. So now we're just going to focus on this in here, okay? So I'll go ahead and write it over here. X squared plus 8x plus blank equals x plus blank squared. All right, well, what do I do to get this number in here again? Well, if we look back on the previous video, right? All we do is just take this term and divide it by 2, right? If we divide that by 2, we're going to get 4. And then what do we do with the 4 to get the number that goes here? Well, 4 times 4, right? Which gives me 16. So that's the number that we want to add. So inside the parentheses, we want to add 16. So we're going to do it just like how we added it before in the other videos. We got x squared plus 8x plus, well, we're going to add the 16. Okay. Now, just like before, we're going to subtract the 16. Okay. But there is one special condition, right? Now, you have to understand, before, when we had this problem, the 16s canceled out to give me 0. And that was really important because we cannot change our equation. But we have to be careful, because if we were to distribute this 2 out, right, we will get 2 times 16, which will give me 32. So we have to be careful, because if we're going to subtract by 16, 32 minus 16 is not going to cancel out. right? We want it to be 0. So when we do problems like this, to ensure that they cancel out, we have to multiply this number by our dilation, which was 2, right? We have to multiply this by 2, which is this number here, right? And if you wanted to, you could verify this. Well, look over here. What's 2 times 16? That's 32. Minus, what's 16 times the 2? Again, that's going to be 32. Perfect. That gives me 0 and they cancel out, right? So that's why we always have to multiply by the dilation in this case. And then don't forget, like before, where we still have this plus 3, right, from right here. Okay. Now, if we look here carefully, okay, if I go to write this again, y is equal to 2. Well, I want you to focus. Right here, x squared plus 8x plus 16, we have this right here. What does that equal? That's right, you are correct. That equals x plus 4 squared. So we can rewrite this whole thing as x plus 4 squared. Okay. Well, now we can write over here, well, this is going to be minus 32, right, plus 3, right? Negative 16 times 2 gives me the 32, but we still have the plus 3. Okay. Then we go ahead and write that as y is equal to 2x plus 4 squared, right, minus 29. And that's it. We just converted from our general, which was this initial equation up here, into its vertex form. All right. Awesome. Let's go ahead and do another one. Let's go ahead and do, let's say y is equal to, I don't know, let's do something like negative 4.9 x squared plus, we'll do 12x plus 7, right? Something that's not going to be very nice, all right? So here, this one's going to be a little tough because we're going to have to be working with decimals. So because that's the case, I'll go ahead and open up my graphing calculator because we're going to have to work probably with decimal numbers or something like that, right? So I'll keep that here just in case. All right, so let's go ahead and get started, right? We're going to get y is equal to, right? Well, we need to pull out the number in the top here, right? So what did we do before to pull that out? Well, we just divide by it, right? So we know we're going to get negative 4.9. Okay, to figure that out, well, we're going to divide this by negative 4.9. Okay, well, this is negatives cancel out, and we're just going to get x squared. And we had to divide this by negative 4.9. So if I go ahead and do that, this is what I need in my calculator. 12 divided by negative 4.9 gives me, oh, it's going to be a terrible number, minus, oops, negative 2.45. Negative 2.45. Okay. And then we have the x. Okay. And then we still have this plus 7 on the outside here, okay? So now to go ahead and complete this problem, all right, well, we want this in here to be a perfect square. So we're going to write x squared minus 2.45x. I'll write this. Let's write this over here. We'll just do it underneath. X squared minus 2.45x plus blank is equal to x plus blank squared. Okay, I'll go ahead and write this lower here. All right, well, what do we do to the middle term? It doesn't matter what the numbers are, whether they're negative or not. What do we do to these numbers here to get the number here? Well, we just divide it by 2, right? We take this and we divide it by 2. So let me just pull out the calculator, right? We take this and we divide it by 2. We're going to get negative 1.224. So I'll just round down, negative 1.22. So negative 1.22. Okay. Last but not least, what do we do to this negative 1.22 to get this number here? Well, we multiply it by itself. So negative 1.22 times negative 1.22. Right, I'll just pull out my calculator. So let's go ahead and do it. Negative 1.22 multiplied by negative 1.22. And we're going to get 1.4884. I'll just round 1.5, all right? Let's just do 1.5. So 1.5. Okay. Perfect. So now we know exactly, right? So maybe I'll just get rid of this so it doesn't distract us, right? Now we know what's the number we want to add inside here. So we're going to get y is equal to negative 4.9. We're going to get x squared minus 2.45x plus, well, 1.5 minus 1.5 multiplied by the dilation, the number that was in front here, so negative 4.9. Okay. Let's make sure that's profound there. Okay. And then we still have this plus 7, right? So we still have this plus 7 right there. Okay. Well, now we know. We just did it, right? This whole thing right here is this right here. X squared minus 2.5x plus 1.5 is going to give me this perfect square here. So I'm going to get y is equal to negative 4.9 x minus 1.22 squared, right? We could do plus minus, but it's just the same thing. And then over here, we just need to simplify this, right? Well, I'll go ahead and just get my handy dandy calculator over here. We have negative 1.5 parentheses, negative 4.9 plus 7, right? And that's going to be 14.35. So plus 14.35. And that's it. We're done. We have solved this problem. It is now in Vertex form, right? A very challenging problem because we're dealing with decimals and it's not going to be super perfect, but this is a very exact estimate of what it would be. All right, cool. Hopefully that helps you to understand how to do it with a dilation, which is what we consider A-level material, right? This is kind of the most challenging ones for these type of